Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 917. Page 917, please turn to it. Problem number 7. There are 3 problems on that page, 7, 8 and 9. They are all medium problems. This section consists of 16 problems. 7, 8 and 9 fall somewhere in the middle, and hence they are medium. Number 7. Josephine's daily exercise routine consists of swimming, cycling and running in that order. We must pay attention. She swims, she cycles, and she runs in that order. So I'm going to put a box around it to remind us that it is fixed. We cannot change the order. She has a very strict regimen that she follows. In other words, she does not go around swimming and running and bicycling willy-nilly. There is a certain pattern that she follows. There is a certain routine that she follows. Yes, I know, I said willy-nilly. I learned it somewhere and I wanted to use it. Okay, let's go on then, shall we? In that order. She runs faster than she swims. Alright, she runs faster than she swims. So R represents here the number of miles she runs per hour. R here is the miles she runs per hour. That's what R is. And S represents the number of miles she runs in the number of miles she swims in 1 hour, and so on and so forth. We are told that she runs faster than she swims. We also told that she cycles faster than she runs. She cycles faster than she runs. Alright, so far so good. What is it they're looking for? If she does not rest between the activities, which of the following could be the graph of the distance that she covers during her entire exercise routine? Well, let's find out. Let's see what we can do here. What you have to understand is that if you were to draw a graph here, let's put this up here so I have the room. She runs faster than she swims, and she cycles faster than she runs. Let's put it up there. What we have to understand is that if you were to put this on the graph here we put our time, and here we put the distance, and we're going to put the time of exactly 1 hour. Exactly 1 hour for all 3 exercises. So what's going to happen now? Because it's 1 hour for all of these 3 exercises, and since these numbers represent the miles that she runs in 1 hour, the miles that she swims in 1 hour, the miles that she cycles in 1 hour, and 1 hour is exactly what we're showing here. So these are just numbers, and now they are no longer rates of travel, because the amount of time is exactly 1 hour. So these rate of travels now are also just numbers. So if you were to show that here, whatever number of miles that she runs in 1 hour, let's say it here, miles, let's suppose that she runs this many miles in 1 hour. Right here, starting with 0. Whatever number of miles that she runs in 1 hour has to be more than the number of miles that she swims. So swim has to be a little bit lower somewhere. We don't know where, but whatever it is, it's lower. So this is the graph that shows her rate of swimming. This is the swimming, this is the running. And finally, we are told that she cycles faster even than she runs. So cycling has to be up here, and that will be right there. Now, what you have to keep in mind is that this is not the order that we're looking for. This is not an 8. This is my S. This is S. What we have to keep in mind is that we are told from the very beginning that she does them in this order. This swimming is first. Swimming is first. Then comes the cycling, and then finally comes the running. So if we're going to show the amount of distance that she travels during these three activities during her exercise routine, the graph should look something like this. The graph should look something like this. The very first activity, which is cycling, which is a very shallow slope, very low slope. Right there, that's your cycling. The next activity, the next activity she does is cycling, which is the fastest of all three, which is the steepest slope. So it becomes very steep. It becomes very steep. And then finally, she runs. And that rate is somewhere between cycling and that rate is somewhere between the rate of cycling and the rate of swimming. So that slope, the slope for the running is not as steep as cycling and it's not as shallow as, so it's somewhere in between. So maybe it looks something like this. And that's what we're looking for. We're looking for something that shows us this. It starts out very, very shallow, then it becomes very steep. The first part here is the swimming, then we have the cycling, and then we have the running. Find one graph that looks like this, and that's your answer. And that graph is going to be E. That graph is E. Interesting question, wasn't it? That graph was E. Number 8. Question number 8. In the xy coordinate system, this point here, root 6 and k, we are told is one of the points of intersection of the graph y equals to x squared minus 7 and y equals to negative x squared plus j. And what do they want? Where j is a constant. The question simply is, what's the value of j? Well, it's the point of intersection. We've just been told that this point with the coordinate root 6 and x coordinate of root 6 and the y coordinate of k is the point of intersection. That's where the two intersect. If that's where the 2 points, two graph intersect. For example, if we had something like this, if we have one graph here and another graph like that, if this is where they intersect, their y coordinate has to be the same and their x coordinate has to be the same, which is why it's called the point of intersection, which means their y coordinate here, this value of y and this value of y has to be the same. And similarly, this value of x here has to be same as that value of x, because this point, root 6 and k, these coordinates of a point, root 6 and k, satisfy this equation and that equation. To satisfy an equation means it works for this equation and that equation. So the value of y is the same for both of these equations, so is the value of x. All we have to do is substitute the value of x and y in these two equations, equate them to each other, and solve for j. That's all. So here, whatever the value of the y is for this one, satisfies this point here. So the value of the y here, whatever it is the same as the value of y here, which means x squared minus 7 must equal negative x squared plus j, because this value of y is the same as this value of y, which is k. Y equals k here, y equals k there. Let's see what we can do. Add x squared to both sides, and we end up with 2x squared, and let's add 7 to both sides. No, let's not add 7. Oh, we forgot to substitute the value of x squared, didn't we? Let's start again. This is negative x squared, and now we can substitute the value of the x coordinate, which is root 6. So here we have root 6 squared minus 7, and here we have negative root 6 squared plus. Now keep in mind, this negative is outside the x squared. It's not part of the. In other words, x itself is not negative root 6. X is positive root 6, and this negative is outside x squared. Let me make this a little bit bigger so it's easier to see. Square of root 6 is 6, so it's 6 minus 7 equals negative 6 plus j. We are almost there. We need j by itself, so get rid of this negative 6 by adding 6 to both sides. And we end up with negative 6 cancels out the positive 6, and we end up with a j equals to 12 minus 7, which is 5. 12 minus 7, which is 5. And that would be answer choice A. That's it. Number 9. Question number 9. Let's see what they want there. They're told that if the absolute value of 2 minus x is less than 3, which of the following is a possible value of x? And they give us the 5 values, and our job is to find the one that works. The easiest and the simplest thing to do here is to just try out these numbers starting from a and just keep on going until you find the one that works. Instead of solving this equation in the algebraic way, we could actually solve this thing in algebraic way, find the range of values of x that will satisfy this inequality, and then see which of these 5 values fall in that range. That will be the classical way, the conventional way, the orthodox way, the geeky way, the nerdy way, the traditional way, the algebraic way, the academic way. But we don't care about those things. We just want to get the answer as quickly as possible. So just start plugging in values for the x that they give you, 5 of them, and see which one that works. The first one says 4. So let's put in 4, see what we get. 2 minus 4, 2 minus 4 is negative 2. But it's the absolute value. Absolute value of negative 2 is positive 2. Is positive 2 less than 3? Is positive 2 less than 3? The answer is yes. It is. That's it, we're done. Therefore, x must be 4. X equals to 4 works. If you put in any other value, it will not work. The answer is A. I will show it to you. I will plug in not all 4 of them, but I will plug in 1 or 2 more and I'll show you that they don't work. If you put in x equals to 5, but that's the next value, answer choice B says 5. Here we get 2 minus 5, which is negative 3. And the absolute value of negative 3 is positive 3. And now the question is positive 3 less than positive 3? The answer is no. Positive 3 is not less than positive 3. And similarly, if you plug in even higher number, they won't work. The only value that works is 4. And that's it, we are done. The answer is A. What we're going to do from this point on, which is going to take some time, which is going to take quite a bit of time, but that's only for learning purposes. This is not something we'll do in the real exam, what we are about to do. Do you understand? We're going to actually do this thing the classical way, the algebraic way, purely for learning purposes, as I said. So let's do it. So what does it tell us when we are told that the absolute value of something is less than negative 3? This quantity here, 2 minus x, we are told, is less than negative 3. What this tells us is that either 2 minus x is less than negative 3, which is very straightforward, if this quantity happens to be positive, or it is also possible that 2 minus x may turn out to be a negative number, in which case this will have to be greater than negative 3. This is the tricky part that we have to understand. For example, if x turns out to be, let's find out something here that makes it negative. How about 2 minus 4? You see, 2 minus 4 is negative 2, and the absolute value of negative 2 is positive 2, and positive 2 is more than, this should have said more than negative 3. You see, I'm making it far too complicated. I don't like it. We shouldn't have gone that route, but since I started it, I have to deal with the damn thing. So let's solve it here. Let's solve both of them. Since I started it, I have to finish it. I have no choice. Let's solve for this thing. So negative x, if you subtract 2 from both sides, so this 2 drops out. 2 minus x is less than 3. I'm not going to actually show the baby step because baby step actually makes it annoying. So negative x equals, if you subtract 2 from both sides, this becomes 1. And since we have to switch the signs, this is a negative sign here, so x is more than 1. So that's the one end of our range. X has to be more than 1, we know now. And because we are multiplying both sides by negative 1, and here we know that negative x is greater than negative 3 and a negative 2, which gives us negative 5, and therefore x is less than positive 5. So it falls somewhere between 1 and 5. Whatever the value of the x is, it's somewhere between 1 and 5. That's all. X has to be between 1 and 5, as you can see from here. And the only value among the 5 that they give us that falls between 1 and 5, it cannot be 5. Why cannot be 5? Because if it were 5, 2 minus 5 would be negative 3, and the absolute value of negative 3 is positive 3, and positive 3 is not less than 3, as we just saw a little while ago. Whatever the value of the x is has to fall between 1 and 5. The only value that falls in that range is 4. 4 falls between 1 and 5. But like I said, this was a very agonizing way to do this problem in the real exam. I wouldn't do it. I wouldn't want you to do it. Just make it very simple. Take one of the choices in the answer choices. Start plugging in. We just got lucky here that the answer turned out to be A, but even if the answer had turned out to be E, it still would have been faster than to do this thing and try to keep track of everything. There are more chances of making mistakes here. As you saw just now when I was doing it, there are a couple of places where I was a little confused. Don't go that way. Do you understand? Just keep it simple. Your job is to get the loot and get the hell out of there. Okay? Don't hang around too long. Just go in there, get the job done, and get the hell out. Do you understand? Don't try to do a sophisticated way, because really nobody cares about it. Nobody's going to look at your work. Computer is the one that's grading it, and the computer doesn't care what you did. Computer doesn't care how you solve it. Computer simply wants to see if you pick the right bubble. That's all it is. I will see you tomorrow, okay? Bye now.